we're going to define the ion product of a salt, QSP. Let's look at this example reaction involving lead 2 chloride. If I want to write the expression for QSP, I would simply take concentration of lead ions times chloride ions squared because of the coefficient. So QSP and KSP take on the same form, but I'm going to solve for QSP to determine whether or not a precipitate will form. So that's why I solve for QSP. I want to make a comparison to see whether or not a precipitate will form. So let's look at an example. Will a precipitate of barium sulfate form if I mix sodium sulfate with barium chloride? Well, the first thing we do when we mix solutions, the concentrations decrease by the equation M1V1 equals M2V2. So for sodium sulfate, my initial concentration is 0.001 and my initial volume is 100 mils. We're going to set that equal to M2 times V2. Now V2 is the total volume. We have 100 mils of both solutions, so the total volume is 200. So M2 is the concentration of sodium sulfate, which is 5 times 10 to the negative 4th molar. We're going to do the same thing with barium chloride. M1V1 equals M2V2. Initial concentration, 0.01. Initial volume, 100. Set that equal to M2 times a total volume of 200. So M2 for barium chloride comes out to 5 times 10 to the negative 3rd molar. I want to know whether or not a precipitate of barium sulfate will form. So my equation is barium sulfate breaks apart into its ions, barium plus sulfate. And I'm going to solve for QSP. QSP is equal to the concentration of barium ions times sulfate ions. Well, the concentration of barium comes from barium chloride, which is 5 times 10 to the negative 3rd. And the concentration of sulfate comes from sodium sulfate, which is 5 times 10 to the negative 4th. And so QSP, when I multiply these two together, 2.5, 10 to the negative 6th. KSP for barium sulfates is 1.12 times 10 to the negative 10th. And you would have to be given KSP in order to determine whether or not a precipitate will form. So here's KSP, here's QSP. You compare the two, QSP is greater than KSP. So yes, a precipitate will form when I mix those two solutions. Suppose we want to recover silver from silver nitrate by precipitating silver as silver chloride. So my solid is AgCl. And it tells me the concentration of silver ions is reduced to a value of 1 times 10 to the negative 9th. I want to solve for the chloride ion concentration. Well, KSP is equal to concentration of silver times chloride ions. KSP is given in the problem, 1.6, 10 to the negative 10th. We're going to set that equal to 10 to the negative 9th for silver, and we're going to solve for chloride. So I simply divide to get the chloride ion concentration. Comes out to 0.16 molar. Sometimes the solubility can be affected by pH. Consider this solid, for example, magnesium hydroxide. if I have a basic solution, that will increase the solubility of hydroxide because it's a basic solution. So according to Le Chatelier's principle, equilibrium will shift to the left and produce less products, less ions. So basic solutions depress the solubility. You get less ions, according to Le Chatelier's principle. Acidic solutions would increase the solubility, would do exactly opposite. You would get more ions if you have this solid in an acidic solution. So let's look at an example with magnesium hydroxide. Will magnesium hydroxide precipitate from a solution that contains the salt magnesium chloride, and it's also made with NH3. Well, NH3 is a weak base. So NH3 will produce hydroxide ions in solution, according to this equation right here. If we go back to our weak base problem, NH3 is 0.1 initially. Products are 0. We're just going to have to use x's. And we can set up a Kb expression. Kb, we're given 1.74 times 10 to the negative 5, and that's going to be equal to x times x, and we can do the shortcut, divided by 0.1. So when we solve for x, that's the concentration of hydroxide, which comes out to a value of 0.0013 molar. So NH3 produces the hydroxide. Now let's go back to our solid. Our solid is magnesium hydroxide. Breaking apart into magnesium ions and 2 hydroxide ions. Well, the concentration of hydroxide we just found as 0.0013. Magnesium comes from the salt MgCl2, which we're told is 0.01 molar. I'm going to solve for QSP. Here's my expression. So magnesium concentration 0.01, hydroxide concentration is 0.0013, and we're going to square it because of the coefficient. So QSP comes out to a value of 1.7 times 10 to the negative 8th. KSP for magnesium hydroxide, and again you will have to be given KSP, 1.8 10 to the negative 11th. So I make a comparison. QSP is greater than KSP, so yes, a precipitate will form in this case.